All right, the next question is from 2017. This is in fact a question from 2017, which speaks about energy and work. Now, a monkey climbed a certain vertical height along a vertical rope with uniform speed in 30 seconds. So in this one, the monkey starts here when time is equal to 0 and it reaches the top when the time is 30 seconds. Right. And it is moving at constant speed. Therefore, if the monkey starts here at speed v1, it reaches the top also at speed v1 and it has covered a height of h. So the only change in energy for the monkey is its gravitational potential energy, and that will be mgh. All right, fine. Later, the same monkey climbed the same vertical height. So this height is h again, right? And it starts here, monkey, and it ends here, right? Along a spiral path, height along a spiral path of 74-meter path length. This length, the whole length is 75-meter path length with another uniform speed. Okay. If the monkey applies the same power throughout its motion in both the cases, the speed with which the monkey has climbed the spiral path is right. Fine. Therefore, now we have to understand that it moves at the same speed, constant speed again. So here it's if the speed is v2, it reaches the top at speed v2. No change in kinetic energy. Kinetic energy hasn't increased or decreased. Here also kinetic energy hasn't increased nor decreased, but its potential energy has increased in both the cases by the same amount. That is what you have to be careful. Now, imagine you lift an object like this to a height of 2 meters. Then there will be an increase in potential energy in people. If you do the same thing this way, if you push an object along an inclined plane, and if you take it up by a height of 2 meters, for both these instances, increase in potential energy is same, because gravitational potential energy is equal to mgh. H is the height, not the distance. So here, monkey is going, effectively, it has reached a height of h. Here also, it has gone a height of h. And they are talking about power. Now, we know power for this particular monkey will be increase in gravitational potential energy. Increase in gravitational potential energy divided by time. If you read the question carefully, they have said same power. If the monkey apply the same power throughout the motion in both cases, same power in both cases. So power, and I was explaining all this time, increase in potential energy is also same for both the instances. These two are constants, correct? Because mgh is the increase in potential energy. So time taken to climb the spiral path, that also should be equal. That also should be 30 seconds, because power is constant. This is also constant. These two values, if these two values are equal, definitely time also has to be equal to people, right? So here also, you have to make sure that the time taken by the monkey is 30 seconds. Okay, so monkey takes 30 seconds to move a total distance of 75 meters. They are asking for the speed, not the velocity. They are asking for the speed. So what is the equation for speed, people? Speed is equal to total distance over total time. I'm talking about the spiral path, total time. You are applying the equation for spiral path. Right then, what will be the speed? Means the total distance is 75 meters along the spiral path. Time taken is 30 seconds. Therefore, the final answer is going to be 2.5 meters per second. 2.5 meters per second, and that would be the second answer. So, from the information given, you should figure out time taken by the monkey to reach the ceiling is 30 seconds. The next energy work question is from 2019, 31st MCQ in the 2019 paper, right? A ball is dropped freely to a flow from a height of 1 meter. If its speed is reduced by 25% at each bounce, what would be the height the ball reaches after 3 bounces? Right, interesting. So let's do it as a sequence, the question, then it will be easier for us. So first of all, they are dropping the ball from a height of 1 meter. So initially the velocity is going to be, initial velocity is going to be 0 for this, but the initial height, let's mark it quickly, 1 meter. And what is the mass of the ball? They have not given the mass of the ball. We don't need the mass of the ball. Right, fine. Okay, now what you have to understand is this. The ball will reach the ground. Okay, and now it will bounce back. It will bounce back. I will draw the way it bounces back like this. Okay, so careful. Now when it hits the ground, let's say the velocity is v1 when it hits the ground. So when it bounces back, guys, tell me what will be the velocity. If its speed reduces by 25%, it's speed. They are carefully using the word speed because it's the, we can't say velocity, direction is changing now. So speed is v1. Now here the speed will be 0.75 v1. Hope you can understand that. If not, okay, 0.75 v1 because 25% is reduced. If 25% is reduced, 75% is retained. So I can write either 0.75 v1. If not, see if you can understand this. So out of 100, 75% is retained. 25 is lost. Yeah. So you can say 3 by 4 v1 is the speed as it bounces back, because I'm using that fraction because you can see that fraction is used in the answer. All right. Then what will this object do? This is the first time it bouncing, first bounce. So I'll just take it as first bounce, and then the object will go up to a new height, and then it will reach 0 velocity and it will come back down. And when it comes back down, what will be its speed, people? Its speed will be this. That is 3/4 v1. It will go up and come down because they are not saying there is air resistance. So if there is no air resistance, if it goes to a height, it will come back the whole height. And when it returns to the ground, the velocity will be same as it goes up and it comes back down the same. Now again, it's going to bounce for the second time. When it bounces back, what will be its speed now, people? It will be, see if you can understand, 3v1/4. That is the speed at which it reached the ground. And I have to multiply that again by another 3/4 because it will reduce by another 25%. So only 75% of that will retain. And now the new velocity is how much? 3/4 squared v1. Okay. Then the ball will go up again, and it will reach a new height which will be lower than this height, that is v equal to 0, and then it will come back to the ground again. And when it comes back to the ground again, what will be its speed? That will be 3/4 squared v1. It went up at 3/4 squared v1. It will come back down at 3/4 squared v1, and again it's going to bounce back for the third time. First bounce, second bounce, and this is the third bounce. And when that happens, what will be the new speed, people? That will be 3/4 squared v1 into another 3/4, because speed is going to reduce by 75%. Therefore, the new velocity is going to be 3/4 cube v1. That will be the new velocity at which the ball is going to bounce back. So you should do this analogy and figure this out. Each instance, speed is reducing by 25%. So if its initial speed was 100 meters per second, if it reaches the ground, when it bounces back, it will be 75 meters per second. So if you take this as v, then it is, so this is 3v/4, right? That is what we have taken here. Fine. So we know the final answer, that is 3/4 cube v1. But the answer is not that. Okay, wait. What would be the height the ball reaches after 3 bounces? Okay. Then after that, the ball will go up and reach a new height. We need to find this height. This is the height they are asking us to find out. Careful, huh? This is the height they are asking us to find out. Yeah, interesting. Okay, fine. This is the height they are asking us to find out. So what is the equation for that, people? Now, in every case, This is what's happening. Here the velocity is 0. Here there is a velocity. Okay, and the object is reaching a height of h. So you can find a quick relationship between these two. That is, this is A, this is B. If you take this point as A and point as B, potential energy at A, gravitational potential energy at A is equal to kinetic energy at B. Correct? So what is the potential energy at A? mgh. Kinetic energy at B is half mv square. So if you simplify this equation, you must have done many times. V is equal to, if not, okay, h is what we are supposed to find out. H is equal to v squared by 2g. V squared by 2g. H is equal to v squared by 2g. All right, fine. So let's apply that to this part, first part, because I don't know v1. I'll apply this here, that equation here. So the equation is h equals v squared over 2g. Now what is h for this case? 1 meter. And what is v squared? v1 squared over 2g. That means I'm getting v1 squared is equal to 2g. That is the equation for the first instance. And now let's apply that equation for this instance. What is the equation? H equal v squared over 2g. Okay. Now what is h for this part, the last part? That is capital H, which we are supposed to find out. And v squared, now you have to be very careful. That will be 3 over 4 cube v1 whole thing squared divided by 2g. All right. So that is equal to what? 3 over 4 to the power 6 into v1 squared over 2g. I'm applying this equation for this part and for this part separately. All right. So what will happen? What is v1 squared, people? What is v1 squared over 2g? Look at v1 squared over 2g. That is 1. So for height, the final answer is going to be 3 over 4 to the power 6 meter. Okay. Right. So the correct answer for this question should be fourth one. First, you have to figure out the final velocity after the third bounce. At which final velocity will the object recoil or bounce back up? And then you have to apply the equation for the first part and the second part. Sorry, first part and the last part, the kinetic energy, gravitational potential energy equation. Find a relationship between velocity and height, and then apply it. All right. The next question is the latest one from 2020 paper, 49th MCQ. Let's see what it says. Now, yeah, this is the random answer. We don't know whether it's correct or not. Scan from student's paper. Block A of mass 2 kg and block B of mass 6 kg are placed on a frictionless horizontal surface. Two identical springs of negligible mass are fixed to the block as shown in the figure. Block A is projected with a speed of 2 meters per second towards block B, which is at rest. So block B is initially at rest. This is just before the collision. All right. What is the maximum energy that the two springs could attain? Fine. So what's going to happen? There are two springs here. You know, when the when object 2 kg comes near this, these two springs are going to get compressed to the maximum, and then these two objects will move together after they meet. So that's what's going to happen. The springs will be compressed and the objects will move together. 2 kg and 6 kg will start moving together because the springs are compressed. And the ground is smooth, so no one is there to stop them. Both the objects now will move together. 2 kg and 6 kg, they will move together at a new speed v. All right. So let's find out how much energy is going to be transferred to the springs. That's the question. Fine. So I'll just compare the energies. Look at the, just now this is before and this is after. Before the collision and after the collision and combination. Right. Now before the collision, if I calculate the kinetic energy, now initial kinetic energy of in the system. What is initial kinetic energy system? This is at rest. Only A is moving. I can say half mv squared. That's the equation anyway. Half into mass is 2 into velocity is 2 squared. And that is 4 joules. The initial kinetic energy. And after the collision happens, the final kinetic energy. Now the blocks are moving together. We need to find out this velocity to find out the final kinetic energy. So I'll just say half mv squared. that is half into mass is 8 into V squared. We haven't found it yet. We have to find that. How do you find this V? For that, obviously, you have to use momentum. We know final linear momentum should be equal to initial linear momentum. This is a system where the resultant force in the total system is 0. This spring will be pressing that spring will be pressing this. So according to Newton's third law, both the objects will be experiencing the same force in the opposite direction, smooth surface. So overall resultant force is 0. So you have the liberty of using conservation of linear momentum. Now, what is the final linear momentum? That is mass 2 plus 6, the total mass, into velocity. And the initial linear momentum is 2 into 2. Only this object is moving. 8V is equal to 4. Therefore, you will be getting V equals 0.5 squared. Sorry, 0.5 meters per second. That is the velocity of the blocks when they are combined. Right. So I will substitute that here. That is 0.5 squared. Guys, 8 divided by 2 is 4. 0.5 squared is quarter. 4 into quarter is 1 joules. Okay. So initially we had 4 joules of kinetic energy, and now we have only 1 joule of kinetic energy. 3 joule of kinetic energy is missing. So what happened to that 3 joule? Change in kinetic energy. Okay, change in kinetic energy is equal to 3 joules. So this 3 joule is the kinetic energy lost. The kinetic energy can be lost in different ways. Now springs are compressed. Now imagine when you have a spring like this, when you compress the spring with a ball or something, and when you release it, the ball gets an energy. So when you compress or extend the spring, for that matter, energy will be stored in the spring. So in this case, energy is stored in the spring, and this 3 joule might have been converted to sound energy because they are colliding, no? Sound energy. Sometimes some amount of heat might have been produced. Okay, so they're asking for the maximum energy that the 2 springs could attain. By maximum energy, they mean, imagine if there was no sound, there was no heat energy produced, all the change in kinetic energy should be converted to the energy stored in the springs. That's why the term maximum energy is used here. Hope you can understand. Okay, so it's just a matter of this. So maximum possible energy stored in springs should be how much? 3 joules. Because the change in kinetic energy is 3 joules, people. That 3 joules could have gone, could have changed to many things. Energy stored in the spring, it could have been converted to heat energy, it could have been converted to sound energy, stuff like that. But they're asking for maximum, so we have to assume that there is no heat energy, there is no sound energy. All the change in kinetic energy is converted to the energy stored in the springs. So for this question, correct answer is the 4th one. Okay, it's just easy. You have to apply law of conservation of momentum, calculate the initial kinetic energy and the final kinetic energy, find the change in kinetic energy, and that's the energy stored in the spring. Right. So